Hello everyone. This video introduces MATLAB cell arrays. To begin, let's review MATLAB classes in general. MATLAB includes 16 different classes or data types. Each class is in the form of an array or matrix. The matrix or array is at a minimum 0 by 0 size. The fundamental classes in MATLAB include logical, string, numeric, table, cell, and structure. And notice hierarchically in the tree, they all start from a matrix or array. Structures or struct and cell arrays are interesting because they allow storage of different classes assigned to a single variable. The cell arrays and structures both have containers to store data assigned to a variable. And starting with the cell arrays, the containers are called cells. And each cell can contain different data types. How do we create cell arrays? Cell arrays are created using curly brackets. So the curly brackets are analogous to square brackets for a matrix or an array in general. So if I make an assignment statement with the variable in an empty set of curly brackets, MATLAB will create an empty cell with size 0 by 0. So let's add some data to the cells of the cell array variable name. So I'm using curly brackets, and within the curly brackets, let me give you some space here so we can see it. Within the curly brackets, we have containers or cells that are separated by commas. So I'm going to open up the variable pane, variable viewer, so we can see the results. And indeed, right now, the cell array is empty, 0 by 0. If I populate the cell array, we can see clearly the different data types. And the column width. So the cell array now has dimensions 1 row by 6 cells. 1 by 6 cells. The first cell, the 1 by 1 element or 1 by 1 cell, is a matrix. The second cell, 1 by 2, is an empty matrix. The third cell is a string, and the fourth cell is a character. So the string has double quotes, character is designated with single quotes. The fifth cell is actually Boolean. It was from the true value. And now look, it's interesting. The sixth cell is actually a cell within the cell. If I double click on the cell, I open it up. So now there's a little hint at the top, the cell array, and it's open and close curly brackets 1 by 6. And it actually has 3 elements, 3 cells, containers in that cell. We have a column vector, a row vector, and a string. So we have a couple of methods to access the data in the cells. And it's going to depend upon if you want the cell or the data in the cell. For example, my variable is the cell array. Maybe just if I index using curly brackets, let's take a look at curly brackets 1 and close curly brackets. I'm getting the data in cell 1, which was the numerical matrix, 2 by 3 matrix. If I compare that to parentheses, number 1, what do I get? Indexing with parentheses, I receive or I access the cell itself. And that cell has data in it. The data is a 2 by 3 double matrix. So if you're interested in accessing the cell, you could index using parentheses. But if you're interested in accessing the values or the data inside the cell, or the container, if you will, you could use the curly brackets. So let's take a look at the sixth cell, which included the cell array within the sixth cell. So I'm going to use curly brackets 1 comma 6 and close curly brackets. So now I expect to see the data within that cell. And it does return, well, what's in the cell is another cell array. So if I want to access the data, let me create an assignment statement. So I have a variable t is going to equal to the cell array with curly brackets 1, 6, and I want the third cell. I want to get the element or the data in the third cell using curly brackets assigned to the variable t. And that is the string. It's the string array, right? I can work backwards. If I want the second cell, I could use curly brackets. And just to compare, let's do the same with parentheses. So if I want the cell and not the data, well, I could use parentheses. So I have curly brackets 1/6, which is the data in the cell of the cell array, the variable name the cell array, and then I'm using parentheses for the second cell of 1,6, and that returns a cell array. So now if I want to access the values of t, I would use curly brackets, because t is a cell array, which again, if you think in terms of a container, what's inside that container or what's inside that cell, well, it's a row vector. So if you want the container or the cell, index using parentheses. If you want the container, the values or the data inside the container or the data inside the cell, you index using curly brackets. I'm going to go create another cell array, a little bit more practical, other than the abstract example we gave here. And say my cell array is going to be an array of material properties. In this case, I'm including two materials, steel and aluminum, modulus, density, and Poisson's ratio. So I open up curly brackets and then I populate the cells. And let me highlight the fact I'm opening up curly brackets. And again, each cell is separated as you would with a matrix in MATLAB, with commas or semicolons. So I have a new row operator. So I expect this to be a cell array of 2 by 4, I'm sorry. 2 rows by 4 cells. 2 by 4 cells. And that's what we get. So we have a 2 by 4 cell array. I open up the variable window, double clicking on the variable name in the workspace pane. Now the first cell is a string for steel. So we have 1, 1 cell. If I double click on a cell, I now have material properties. If I want to get the actual data in the 1, 1 cell, use curly brackets. It returns the string array of steel. What if I was looking at the first row? Okay, so second row, column 1 is the aluminum. So the density of aluminum, I'm looking at the 2, 3 cell, second row, third column of the cell. with curly brackets, it's returning the value of the density of aluminum. So accessing or assigning material data to the cells or containers, if you will, is analogous to accessing and modifying elements of a matrix or array in general. The only thing you need to keep in mind is, are you accessing the cell or are you accessing the data in the cell? Difference being, data in the cell is accessed through indexing with curly brackets. Accessing the cell itself is parentheses. So keep in mind, if you go back to the cell array example, right, the 6th cell is a cell array, right? And within that cell array is 3 additional cells. Each one of the cells or containers has the data. So we can create, just to repeat, is a empty cell. Or we could use the cell function. So C2, MATLAB cell function. Now I'm going to make a cell array using the cell function 2, 3, and it creates a cell array of empty cells. 2 rows, 3 columns, and each of the cells are populated with what? Remember, the default class or the default data type in MATLAB is a matrix of doubles. So we have 0 by 0 double of each of the empty cells. So, I want to access the cell array for the material properties of steel. So I'm going to create an assignment statement with a variable named steel, and I want the first row of all the columns. So as if I were indexing a numerical matrix, first row, all the columns, I'm using a shortcut colon operator, specifying number 1 for the first row, and I'm using parentheses. So I want to make steel a cell array that contains only the material properties for steel. And that's what I have. So now I have a new cell array called steel, and it has 4 cells. If I want the value of the density of steel, I would use curly brackets for the 3rd cell, and now that's returning the value of the data stored in the 3rd cell as a double type for A and S. And so A and S, the default variable in MATLAB, size 1 by 1, has the value 7850, and it is a double class. Everything else in the workspace is cells, cell arrays. So, cell arrays have containers that are called cells the same way a vector has elements, or as a matrix has elements. If you have a matrix of 2 by 2, there's 4 elements in the matrix. The big difference and the big advantage of the cell is, remember, a matrix could only contain all of the same data types. So if you have a matrix of numeric value doubles, they all had to be doubles. If you had a matrix of Booleans, they all had to be Booleans. But a cell array can have different data types or classes in each cell. And we see that if we go back up to the cell array variable. Cell 1 was a matrix. Cell 2 was an empty matrix. Cell 3 was a string. Cell 4 was a character. Cell 5 was a relational Boolean operator, true. And cell 6 actually had another cell array within the cell. So it's a very convenient, very flexible way to assign and group related data of different data classes to one variable name. So for example, my material properties, I could pass that into a function and access the appropriate material properties for steel or aluminum. So that's the introduction to cell arrays. Keep in mind, in practice, parentheses versus curly brackets when indexing or accessing the information from the cell array. Do you want to return a cell array, or do you want to return the data in the cell? And keep in mind also, cell is synonymous with container, which is analogous to an element in the matrix. Thank you.